One honors. I'm sorry I couldn't be with you, but I'm going to do a little video of the lesson for today. I'm going to walk through this chapter 8a, Pythagoras' Theorem, which maybe you've heard of, maybe you've studied it a little bit, and I'm going to walk through a few examples of kinds of problems that we need to know how to do. This is the textbook that you use. This is page 169. You should be able to see it up here. And I'm just going to walk through a little bit of the chapter and explain a few things to you and show you an example or two before you practice some problems. So you can just watch this video. I would like it if you get your math notebook out and you copy down the examples and formulas that I talk about now into your notebook so that you have it saved. Please pause the video now to take out your math notebook. And before we get started, if you can also put in your learning objective paper at the front of your notebook, number 8a. That's 8a, Pythagoras' Theorem. You can pause the video now to write that. All right, well, I'm going to start talking about Pythagoras' Theorem. I'm going to scroll down to the beginning of the unit here. Pythagoras' Theorem, 8a. Pythagoras' Theorem is all about right-angled triangles, like you see in the picture here. Notice that we have two legs, and we have one side that's called the hypotenuse. Why do you think this side is called the hypotenuse and these two are called the legs? Well, if you said that the legs are the two sides that meet at the right angle, you'd be correct. The legs are also the shortest two sides. The longest side is called the hypotenuse. That's a Greek word. So now that we know about the three sides of a right-angled triangle, let's talk about a formula that helps us to find the lengths of all three sides. Here it is, Pythagoras' Theorem. It tells us that in a right-angled triangle with the hypotenuse as the letter C in our formula and the legs as A and B in our formula, we can connect the three sides with the formula that the hypotenuse squared, C squared, equals A squared plus B squared. You may have found this from this picture down below with the three squares, just like you did for your investigation. A squared plus B squared equals C squared. That is called Pythagoras' Theorem. Please write down this formula in your notebook and give it the title Pythagoras' Theorem. Great. Let's look at an example of a kind of problem that we might use this to help us to solve. All right, example number 1. I would like it if you would copy down this drawing of this triangle into your notebook now. Pause it if you need to. This triangle has three sides. What are the lengths of the legs? If you said 2 centimeters and 3 centimeters, you would be correct. Those are the two shortest sides. The hypotenuse, we don't know the length of, so we call it x centimeters. X. Let's look at how to solve this problem now. I'm going to kind of hide it a little bit. So, do you remember the formula? Well, we can see it here. A squared plus B squared equals C squared. Remember that C is the hypotenuse. In this case, it's x. So we can set this up as x squared, the longest side squared, equals 3 squared, the shortest side squared, plus 2 squared, which is the other side squared. Now we have an algebra question for us to solve. What is 3 squared and what is 2 squared? Well, as you can see, x squared equals 9, which is 3 squared, plus 4, which is 2 squared. That was easy. Let's continue on. X squared is 13. You can probably see that we added 9 and 4 to get 13. What is our next step here? We want to solve for x, but we have x squared equals 13. We need to take the square root of each side of this equation. That will make x squared become x. And we take the square root of 13, it gives us the square root of 13. If you go to your calculator and you calculate the square root of 13, you should find the hypotenuse is about 3.61 centimeters long. The hypotenuse is x. we've solved this problem to find the length of the hypotenuse. We should write 3.61 centimeters long. So take a moment to copy this down into your notebook. Pause the video if you need to. Now let's look at example number 2. Example 2. Find the length of the third side of this triangle. What is different about this triangle? Well, you probably noticed that this time the side that we do not know is one of the legs, not the hypotenuse. So we're going to set up a formula using the same formula, but a little bit differently now. Notice that we put x squared plus 5 squared equals 6 squared. 6 is alone with the squared because 6 is the hypotenuse. Great. Now let's square the numbers that we know. We can say x squared plus 25 equals 36. What is our next step? If we want to get x squared by itself, we need to take this plus 25 and we need to subtract it from both sides. That'll give us x squared equals 11. So if x squared is 11, 11 plus 25 is 36. Awesome. Well, how do we undo x squared equals 11? We need to take the square root of both sides. That gives us x equals the square root of 11. Great. So this missing side is the square root of 11. From our calculator, we can go ahead and type that in, and we can find a decimal value. The third side is about 3.32 centimeters long. All right, that's our example number 2. Notice that so far we've been working with whole numbers like 5 and 6. Example 1, we found the length of the hypotenuse, where x is on its own side. Example 2, we found the missing length of a leg. That's why it was on the same side with 5, the two legs together. Great. I'm going to jump down to example number 3, our final example. All right, we're going to do 3a, which is right here. Find the side x in surd form. Do you remember surds? Surds are these numbers inside of these root symbols. All right. How do you think we could set up this triangle in Pythagoras' theorem? Try to write that down and also copy down this triangle into your notebook. All right, you should have found that we could write that x squared, which is the hypotenuse squared, equals 2 squared plus root 10 squared. All right, let's see what happens now. I think you know how to square the number 2, but how do we square root 10? Well, root 10 times another root 10 should just give us 10. Now we have x squared is 4 plus 10. That's 14. And this time, we'll write x is root 14. In this question, because it says find x in surd form, we do not need to go to a calculator. We're just going to leave our answer as the side x is root 14. I hope that makes sense to you. I'm not going to explain part B, but you should go ahead and pause the video and try to look at this example, follow along in the steps, and see if it makes sense to you. Great. Now, when the video finishes, your homework assignment is to go down to exercise 8A.1, which is on page 172, going into page 173, and you're going to work on questions 1, A, B, and C, and then questions 2, A, B, and C, and questions 3, A, B, and C. I think that'll be it for now. The other ones we'll talk about a little bit later. Good luck. Watch this video again. Go back to the examples if you need help. And please work on exercise 8A1, all of number 1, all of number 2, and all of number 3 in your math notebook. Thank you for watching. See you next class.